we'll discuss about structure of glucose. So we know glucose is an aldohexose, which means there are 6 carbon, 1, 2, 3, 4, 5, 6, 6 carbon with aldehyde as a functional group. This is the most oxidized carbon, so which is at the top, which is numbered as 1. So 1, 2, 3, 4, 5, 6, they are numbered in that way. Now, you know from 2 to 5, 2, 3, 4, 5 are chiral centers. And on the one side you have OH, on the other side you have H. You can see from 2 to 5 they are chiral centers. And at the bottom on 6th carbon you have CH2OH. Now you can remember easily the structure. See, from 2 to 5 it is chiral centers, and on the either side you have OH and H. From here onwards you remember like this. On the third carbon, 1, 2, 3, on the third carbon on the right side it is H. On 2, 4 and 5 on the right side it is OH. 2, 4 and 5. So this is a way how do you remember easily the structure of the glucose. At the top or on the first carbon you have aldehyde. At the bottom you have CH2OH, that is on the first carbon aldehyde, 6th carbon CH2OH. 2 to 5 they are chiral centers. So there are 4 chiral centers, and this structure is sometimes referred as open structure. So open structure contains 4 chiral centers. Now on the third carbon right side you put H, on 2, 4 and 5 right side OH. So this is the way how do you remember very easily the open structure of glucose. Now here we will discuss a hemiacetal structure of glucose. See, first of all we will discuss what do you mean by a hemiacetal. Here you have an aldehyde here, R C double bond OH, aldehyde, and there is an alcohol. Here you have an alcohol, R dash OH. When an aldehyde reacts with an alcohol, the product is called hemiacetal. See what happened? This alcohol will be added to this carbon. Whenever this alcohol is added to this carbon, this C double bond O will be shifted over to oxygen, and this hydrogen will be added on to this hydrogen, so it will become C single bond OH, and this OR will be added to this carbon. So what's the net result? It will become COH single bond OH, C single bond OR, and these are the existing one, R and H, R and H. So this group C double bond O, one side becomes COH, other side becomes COR. That means here the R is the alkyl group of the alcohol, and this is aldehyde. So between this is the aldehyde, this is the aldehyde. Between the aldehyde and the alkyl group of the alcohol, they are connected through oxygen. Such a linkage is called the glycosidic linkage. Through oxygen, this aldehyde is connected to the alkyl group of alcohol. R dash is the alkyl group of alcohol. This is hemiacetal structure. Look on your glucose. This is glucose. They are numbered as 1, 2, 3, 4, 5. Now we will draw the hemiacetal structure of glucose and how it is possible. Look, easy. From the 5th carbon, this OH is added to the first carbon. How it is possible? This OH is added to the carbon. Subsequently, C double bond O is shifted to oxygen. Look, this C double bond O is shifted to oxygen. So what happened to this carbon? And alcohol is added. Look onto here. Alcohol is added to this carbon, so that carbon becomes OH, OH, HOH. Here you have H, here you have OH. So this C double bond O on C, look onto here, one side become it is OH. This is OH, and on the other side, on the other side it become H. See, this was the first carbon. To this first carbon, the OH from the 5th carbon is added. So what happened? This is hemiacetal formation. So on the first carbon, one side become OH and other side become H. Remember, what is next? So here between the aldehyde and the alcohol group, alkyl group of the alcohol and linkage is through oxygen. So this was the carbon, or this was the alkyl group of this alcohol. So between this alkyl group of the alcohol and this aldehyde, because aldehyde, there is a linkage through oxygen. There is a linkage through oxygen, and this is called a hemiacetal structure. Clear? Now what happened? Earlier in the open structure, 2, 3, 4, 5 were chiral centers. 2, 3, 4, 5. But here what happened? The first carbon also become chiral centers. So 1, 2, 3, 4, 5 become chiral centers. I hope it is clear. So there is a linkage between the first carbon and the fifth carbon through oxygen, and this structure is known as hemiacetal structure. Now listen. See, actually whenever this was added, the alcohol is added to the first carbon. See, the COH here it become on the right side, and there's an equal possibility the same OH group on the first carbon may come on the left side also. Clear? So you can have two structures whenever the OH group from the fifth carbon is added to the first carbon. What are the two possibilities? One, after addition the first carbon becomes CHOH. This carbon becomes CHOH, first carbon. So that OH may be oriented on the right side or maybe on the left side. If it is on the right side it is called alpha D glucose. Alpha D glucose. If it is on the left side it is called beta D glucose. So there are two forms of glucose, alpha D glucose and beta D glucose. Alpha means the first carbon. This first carbon is called anomeric carbon, which means that contains the functional group aldehyde. On the anomeric carbon, the OH is on the right side, so it is called alpha. D stands for on the fifth carbon, which is the farthest chiral center, the OH is on the right side. That's why it is termed as alpha D. So it is alpha D glucose and this is beta D glucose. And this pair of alpha and beta D glucose, it is a pair, they are stereoisomers, and that pair of stereoisomer is called anomers. Anomers, A-N-O-M-E-R-S, anomers. What are anomers? A pair of stereoisomers in which the orientation is different only on the anomeric carbon. Look onto this structure as well as this structure, 1 and 3, or 2 it is represented here, 1 and 2. What is the only difference? 2, 3, 4, 5, 6. 2, 3, 4, 5, 6, they are similar. But on the first carbon, the OH is on the right side, and here on the second carbon, on the first carbon, the OH is on the left side. And such a pair is known as anomeric pair. Thank you.